Students, in this lecture we are going to study cubic spline curve in detail. So previous lecture we have seen that cubic spline curve has mainly two types, or any curve can be represented with two types, interpolation and approximation. So when we consider interpolation, it indicates that when it passes through all the control points, then we call it as a interpolation curve. And when it passes through only first and last, not all the control point, not necessary that it pass through the all control points, then we call it as a approximation curve. So in this lecture we are going to study this cubic spline curve in detail. The cubic spline curve is nothing but the interpolation curve, and that has mainly represent with two types, that is parametric continuous condition and geometric continuity condition, and that part also we have seen in the last lecture. Now here we are going to see the equation of cubic spline curve, how to represent the cubic spline curve with the equation or geometric continuity condition. Suppose we have following parametric cubic polynomial representation for x coordinate. So x coordinate, how we represent, for example it is a 3D curve. So x, y and z, three coordinates are there. So t represent the position vector at that particular coordinate. So here how we represent it with x coordinate? It is represented as, for example if we consider it is a cubic, means its a degree is 4 control points and polynomial degree of 3, and that is why we call it as a cubic curve. So we call it as A, this is point B, this is C and this is D, and suppose the curve is like this. Okay, so A, B, C and D. So the xt is represent, the position vector at x coordinate is represent as ax t cube plus bx t square plus cx t plus dx. Okay, so in this way we represent xt. Now we can represent it with the matrix form like this t cube, t2, t1, t raised to 1 and 1 multiply with ax, bx, cx and dx. We call it as a t multiply with c, we call it as a matrix C. Now this is for xt only. Now remaining yt and zt, how we represent it with this xt is equal to, we have already seen the yt, instead of x we use here term y as indicate the y coordinate or y axis. So ay t cube plus by t square plus cy t plus dy, and in the same way we represent zt. So the entire thing or all these three equations, how we can represent it with the matrix? We can represent is qt is equal to xy, xt, yt and zt, three coordinates, t multiply with c. So what is t? T is common here for all these three equations, t raised to 3, t raised to 2 or t square, t and 1, and c is ax at the first ax, then ay, az. Similarly bx, by, bz, cx, cy, cz, dx, dy, dz, and we will get these three equations. So these three same equation we represent as a matrix form. Now this cubic spline curve, when we represent it matrix form, it is like this. Qt is equal to tmg. So t already we have seen, this is t raised to 3 cubic form. So start with polynomial of degree 3. So t raised to 3, t square, t and 1. mi comma g, it represent the x and y coordinate, and g is the geometric condition or geometric coordinate. So see here, m is 4 into 4 basis matrix and G is 4 element column vector of geometric constant called geometric vector. So G indicate the geometric vector. So the curve is weighted sum of the elements of geometric matrix, and this is known as blending functions. So the weights are each cubic polynomial of T and are called blending function. So that blending function is represent with B is equal to this T multiply with this M, 4 into 4 matrix, and G is the geometric condition. Now This cubic spline curve, how we can represent it with the equation? The equation for single parametric, here we consider single parametric cubic spline curve. So again it is a cubic spline, means there are only 4 control points we consider. First one is A, B, C and D. So 4 control points, so degree of polynomial 3. Now use boundary conditions to evaluate the constant coefficients Bi. Now how we represent? There are 4 points, control points. So we represent this Pt. So Pt is a position vector of any point on the cubic spline segment. So on this segment Pt is any position vector. Initially t is equal to always 0 and t is equal, at the end t is equal to 1. So it is from, suppose it is t1 and this is t2. So t is in between t1 to t2, means it is ranges from 0 to 1, any one or any position vector from 0 to 1. So t1 is equal to 0, which indicates the start point, while t2 is equal to 1, which indicates the end point. Now that is beginning and end of the segment. The same equation we write it in another form. Pt is equal to summation of I ranges from 1 to 4, correct. So 4 control points are there. Bi, so it is b1, b2, b3, b4, that is bi, and t raised to I minus 1. Why it is? Because it is start with, or the degree is always 1 less than the number of control points. So here the 4 control points means degree is 3. So it is t raised to I minus 1. So b1, so b1 multiply with t raised to 0, so it becomes b1. b2 multiply with t raised to 1, b3 multiply with t raised to 2 and b4 multiply with t raised to 4, sorry t raised to 3. So in this way the same equation we represent in the form of summation I ranges from 1 to 4 bi t raised to I minus 1, where t is any position vector ranges from t1 to t2. t1 is equal to 0 and t2 is equal to 1. Now this pt with this x, y, z coordinate, it is represent Cartesian coordinates. If we represent it with the radius and the angle, then it represent cylindrical coefficients and spherical coefficient. If there is a radius and 2 angles are given, then it represent the spherical coefficient. Now this cubic spline curve, it is written here for 3 different xt, yt and zt. So it is for x coordinate, it is for x coordinate. How we represent it? As we have already write it in previous slide. So xt is equal to summation of b1x plus, we write it as b2xt plus b3x t raised to 2 plus b4x t raised to cube or t raised to 3. So in this way we represent xt for x value or x coordinate. In the same way we write it for yt, b1y plus b2yt plus b2yt square plus b4yt cube. Similarly for z coordinate. So the constant coefficient bi are determined by specified 4 boundary conditions for the spline segment. So that is 4 conditions A, B, C, D, 4 points are control points are there. Now this cubic spline, suppose we consider that in this case P1 and P2 be the position vector at the end of spline segment. So that is shown in this diagram. This is P1 and this is P2. So this is the starting point and this is the end point of the segment. Also P1 dash and P2 dash, that is derivatives with respect to t. So that derivative means dx divided x coordinate. For x coordinate it is dx divided by dt. For y coordinate it is dy divided by dt, and for z coordinate is dz divided by dt. Also this p1 dash, so this p1 dash is the first derivative that we have seen in the previous slide. So first order derivative, second order and so on. So the P1 dash is the first order derivative for P1, this P1, while P2 dash is the first order derivative of P2. So derivatives with respect to t be the tangent vectors at the ends of the spline segment. So it indicates the tangent vector. So this indicates the direction of this particular curve, and this indicates the direction of this particular curve at this end point on this starting point. So p dash t, it is the first order derivative of p. It is represented as, at x coordinate it is x dash t, at y coordinate it is y dash t, and for z coordinate it is z dash t. How we represent in the form of equation? In our equation, p dash t is equal to summation of I to 4, I ranges from 1 to 4, 4 control points we consider, I minus 1 bi t raised to I minus 2 according to the equation of derivation we write it. So p dash t becomes b2, okay, plus 2b2 as this one I minus 1. So I start with 1. So 1 minus 1 it becomes, see here how we write it, p dash t is equal to summation of I minus 1. So initially I is equal to 1. So 1 minus 1 multiply with bi. So b1 t raised to I minus 1. So what is I? Initially I is equal to 1. So 1 minus 2. So what happens it? 1 minus 1 means 0 multiply with this term. So it becomes equal to 0. Okay. So it becomes equal to 0. So that we are not going to represent. So in next one I is equal to 2. So I is equal to 2, I minus 1. So it is 1 multiply with b2 plus t raised to I minus 2. I with 2 minus 2 it is 0. So 2 raised to 0 is 1. So it becomes b2, this 2 b2 b3t and 3 b4t the according to this first order derivation. So let first initially we consider that t1 is equal to 0, as I will told that t1 is equal to 0. So p of 0. So at this position what is the value of t? It is equal to 0, and that is why it is equal to p1 whatever as it is. While what is the derivative of this? At t1 is equal to 0, derivative is p1 dash. Now we consider this t2. So this t2. So p of t2, this is the end point position vector, is equal to p2, and p dash t2 is equal to the first derivative of p2, that is p dash 2. Now we write this for all 4 equations for 4 points in detail. So first this p1 p naught. So p naught means t1 is equal to 0. For that it is equal to p1, or first position, that is b1. Next p2. So p2 means here this point we are going to derive. What is it? That equation we have written. What is it? Summation of I is equal to 1 to 4 b raised to I t b I multiply with t minus I, and that equation we have already seen in the previous slide, that is b1 plus b2 t raised to 1 plus b3 t raised to 2 plus b4 t raised to 3 is equal to p2. So that is the equation for this end point. Now p dash 0, or the first derivative of this p naught. So the first derivative, that equation also we have seen in the previous slide. What is the equation? It is summation of I ranges from 1 to 4, I minus 1 b dash t raised to I minus 2. So according to this, the values of b2 is p2 p1 dash, that is first derivative. Then if we calculate, put the value here in this equation, put the value 0. So after putting the value 0, we will get it is equal to b2 only. If we put the value 0 in this equation, then we will get here only B2. So, P1 dash is equal to B2. Next, we calculate the first derivative of the end point, that is P2. So, it is summation of, again we use the same equation, and in this equation now we are going to put the value of T2. So, if we put the value of T2, then P2 dash is equal to B2 plus 2B3 T1 2 raised to 1 plus 3B4 T raised to 2. So, that is here. In this way we will get this. According to this we will get this equation for this P2 dash. So, this is the equation for P1 is equal to B1, P2 is equal to this equation B1 plus B2 and this one, P1 dash is equal to B2 and P2 dash is equal to this equation, that is the first derivative of this equation. So, this is the first derivative of this equation, while this is the first derivative of this equation. Now, so solving B1, B2, B3, B4, what we will get after at the end the result? B1 is equal to P1 that we have solved here, B1 is equal to P1 that we have solved here, and B2 is equal to P1 dash. Now, we write it for B3 and B4. So, B1 is equal to P1, that is here, B2 is equal to P1 dash, B3 is equal to, in this way when we put the value in the equation we will get this result, and B4 is equal to this one. So, here P1 and P2 give the position of the end point. So, P1 and P2, this is the first starting point and this is the end point, and P1 dash and P2 dash give the direction of tangent vector. So, it indicates that it is in this direction, the curve goes in this direction. So, that is P1 dash and P2 dash. So, these values, when we got these values B1, B2, B3 and B4, it determines the cubic spline segment together. So, that is here written together. PT is equal to, then it is written for the entire position vector PT. Substituting these values in the first equation, what is our first equation? It is like this. So, the equation is PT, this equation PT is equal to B1 plus B2t plus B3t square plus B4t cube. So, put the values of B1, B2, B3, B4 here, these values whatever we have calculated, put these values here. So, B1 is P1, B2 is P1 is P1, B2 is P2, P1 dash, B3 has this entire value t square and B4 has this entire value. So, thus given the two endpoints, if we are given the first and the last endpoint and the tangent vector, one can compute the cubic spline. So, if we are given the first and last position vector, we can compute the cubic spline. So, for piecewise continuity, suppose we add here another curve, second piece, then for that we find out the same. For that we require to find out the P double dash 2t. So, in this way we need to increase the derivation of that particular tangent vector. That is about the cubic spline. Thank you.